This CNC project is creating on the tool a platform onto which to set an air handler. And I'm going to be placing it on top of the steel platforms that are here, the steel L angles. I'm going to drop it right on top. So here we are at the beginning of a new workday, and what I decided to do is obviously double check all my dimensions. But I do want to modify the profile toolpath to give these tiny radiuses that are here. Not tiny, they're about 1.75 inches is what we're going to do. So I will actually draw those in. I've put a circle. The only thing I've done is place a circle here so I can modify that. It's really not in the right position. Yeah, that should give us kind of what we're looking for with that small radius. What we can do is then trim this using this scissors tool, or I can, what are we trying to do here? Trim the unwanted pieces. So it's going to end up looking like that. It's kind of what it looks like. It is actually, it is what it's like. So we'll do the same down here. And this is an outside corner. And that is, we're right at 65.5 and 2. So let's place a circle at 63. Yeah, 63.75 makes sense. And then on the Y dimension, it would need to be at 3.75, I think. Create. Yeah, looks about right. Let's close. Let's trim. Right on. So this is all getting cut out here because that large conduit. So let's go down into this corner and make one here. Bring back our guidelines. Bring back our circle. We're going to want it to be here. So it's going to be 3.75 on the Y. And then the X is going to have to be 3.75. 3/8. That's about right. Close. Let's trim. And that trim function is I'm comfortable with it because it's identical in AutoCAD. Not that I'm comfortable in AutoCAD, but speaking of AutoCAD, I'm going to be making custom thresholds. So I plan on definitely videos where I'll be drawing in AutoCAD and then importing that into VCarve or Vectric. I'm going to check some dimensions here. No reason to record me doing that. So I'll pause this video. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. I've added grease to my to the rack on the tool, and I'm very slowly moving the machine to get the grease spread around. Yeah, so now it's at a stop. So now what I'll do is move it back down 1, 1, leave it at 4. I have so much material thickness on the bed. Yeah, so I'm just very slowly moving, I mean, really slowly moving the machine to get that grease spread around to the point where you forget it's running. So you can Alt Tab, I find, while it's running, which I guess I'm not recommending, I suppose, but you know, you can Alt Tab to a different program. So I have just this last dimension to really check, 35.5. Yeah, these dimensions they're good. So at this point, we're going to air cut this, but let's create the tool paths for this. And I have to decide what bit I'm going to use. Let's take a look. So for our pocketing tool path, I think what we'll use is my Amana. I bought an Amana T-slotting bit that I intended to use for a different project. Turns out it works it works just perfectly as a spoil board bit. And I don't want to use this bit for this project, but I intend to purchase a larger diameter spoil board bit because I've got an ATC coming. Chris Burns is going to install that. I'm going to be his tool monkey for a couple of days, helping him how to do that. So I'm going to use this Amana. It's a 45662 for this pocketing tool path. Let's click the racetrack, as Chris calls it. Yeah, one closed vector. So that all those radiuses are good there. So let's look at only our pocket tool path. Let's pull in our tool path. Now, I don't No, if I believe I have this bit in here because I have yeah, surfacing end mill. I believe this is it. Yeah, it's an Amana 45662 inch and 3/8 T-slotting tool used for surfacing. Let's pull up some information on this 45662. Definitely don't want to get us in trouble with that. So I am thinking a 0.001, 0.002 chip load is going to be perfect for this. 18,000 RPM is the right RPM for this bit. Cutting pass, step over. I'm going to reduce that to 65%. 18,000. So, yeah, it's a 1 and 3/8 diameter bit. 18,000 RPM. 001, 002 is a good chip load range. Feed rate, 1 inch per second, or 60 inches per minute. A little slow, but I'm good with slow. Plunge rate, yeah, really, really slow. Tool number 7, apply, select. Okay, so we're pocketing. We're going to get rid of our 1/4 inch end mill. We've got our what we call our surfacing bit. Number of passes 10. Well, that's going to be based on our cut depth, which we have not set. So I have to measure to be sure how much pocketing I want. If you recall, I want to be sure that I can get underneath here with a robot vacuum. So let me remeasure that. So we're going to want a 1 inch cut depth. And what I mean by that is the floor to the underside of the angle shown here, that's 2 7/8. I've got an eighth of an inch thick here. That brings me to 3 inch. I'm going to pocket up 1 inch. It's higher than I need, but I expect there to be a small amount of bellying that will occur here. I mean, the load that will be sitting on this will be less weight than the load of the platform itself. So we're going to make a pocket depth of 1 inch, cut depth of 1 inch. 20 passes. Now let's take a look and see what we're doing with that. 0.05. I'm thinking we're going to kick that up. Try an eighth of an inch. Let's go to 8. Edit passes. 8. Okay. Edit passes. 8. Set passes. Okay. Yeah. All right. So a cut depth of 1 inch. 8 passes, an eighth of an inch per pass. No profile pass. Not concerned about that. Ramp plunge moves. Yeah, we're going to want to have that going real gradual because of the type of bit this is. So I'm actually going to increase that to 10. Pocket 1, calculate. Yeah, looks about right. It's going to take a month of Sundays, though, to cut this. Yeah, that makes sense. Our step over is leaving those small little artifacts out there. I believe that's why. And that's okay because, and I have this at full speed. Um, And that's why I extended the toolpath to get off of the workpiece completely at both ends. 65% of the way done. Just want to be able to run through this and then check its depths. All right. So we got a 1 inch depth. And those artifacts that I'm discussing, you can see right here. No problem. Like I said, we're going to end up leaving those. Yeah. You'll never even see them. They won't even exist. Okay, so that looks reasonably decent. So let's close this. Now let's play with our profile toolpath. Cool. Let's do that.
You know what's worse than not knowing where to put the neutral leg on a 3-phase high voltage panel? It's not participating in the Architectural Builders Supply March giveaway.
Okay, now that profile tool path, let's take a look at that. Now we have to select a bit. Let's take a look at what we're going to use for that. Okay, so I have a Onsrud 60-172MW. Let's take a look at what that looks like in their catalog. I should have that catalog pulled up. I don't. 60-172MW. Okay, so this is going to be 1/2 inch diameter, 1 5/8 length of cutter. That's not going to be a problem because it actually comes. It's going to be great. Upcut 3/4, sure. So we're dealing with a compression. That'll give us a clean cut on both sides of it, which is important to an extent that I want it to sit flat without any post work. Overall length 4 inch. Yeah, so this bit's literally it's a 2 flute bit, right? Yeah. So it's going to be real good shape for this. Now that's a 60-100 MW max wear. Wow. Okay. Recommended chip load by cutting diameter 1 inch. It's 1/2 inch. 0.022 to 0.024 for softwood. Let's take a look. Softwood, hardwood, 0.018, 0.02, 0.018, 0.02, laminated plywood, yeah. 0.018, 0.02. Okay, so let's take a look. Let's select a tool. Let's go with this end mill. We're going to call this tool number 9. We've got some multiple number 8s and 4s. Onsrud 60-172 MW 0.018, 0.02 chip. Let's run it's 2 flute pass depth. Yeah, 1/4 inch I think would be absolutely perfect. Let's set this to 12,000. Feed rate.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
So let's figure out what our feed rate needs to be. So RPM, let's take a look at this formula. Let's stick with our 12,000 RPM times the quantity of flutes, which is 2, times our chip load. Let's just say 0.019. We'll go right in the middle of what they're recommending. Actually 0.022 times multiplied by 0.022. 528 inches per minute. So divided by 60, 528 divided by 60 is 8.8. 8.8 inches per second. 8.8. Yeah. 8.8 inches per second? No, there's no chance. The tool will be flying at that speed. No. That's I'm gonna run that just to see if it actually would possibly work. We're gonna air cut that just to see if the machine will react. We got a cut depth, we've got a tool selected. Edit passes. Let's just try 16 passes. Okay. No tabs. Ramps, yeah, we're gonna ramp in. Save C is 0.2. That'll work. Profile 1. Let's reset this preview. Let's preview the selected toolpath. Get it through our workpiece. And it does look like what I need. Reset the preview. Let's preview all toolpaths. Gonna have to make that go really fast. See what the finished product looks like. I'll pause this because this will take a couple of minutes. So we're getting through the pocketing profile, and I want to take a look at the pocketing toolpath. And now we're going through the profiling toolpath. Kind of wanted to capture that, take a look and see what it looks like. Bring it way down now. It'll be our last pass. Okay, so yeah, so we are seeing the underside of this. This is what the bottom is going to look like. Very helpful to model this, that's for sure, because it's been drawn upside down. I've just realized my pocket's on the wrong side of the workpiece. The profile is drawn correctly. The pocket's on the wrong side of the workpiece. So what we obviously want to attempt to do is to take the profile, which is what we're looking at, and flip it, mirror it 180 degrees, I suppose, just mirror it over. That is what we definitely want to do. Mirror selected object. Flip about job center. I believe that's what I want. And I think that I want to flip it vertical. Yes, this is what I want. Create a mirrored copy. So what we want to do here, let's mirror, flip about the job center. Let's not create a mirrored copy. Let's flip it vertical. Yeah, this looks way better now. Yep, because I drew the profile looking at it from the top down, and I drew the pocket looking at it from the bottom up. That's the problem. Let's just let's preview all toolpaths just so that we can take a look and see what it's going to look like. All right, coming up on the profile toolpath now. Let's see what this is going to look like. Speed that up a little bit. Okay. When you double click on something you've cut off in the 3D view, it removes it, which is what I've done. The point of the matter is I just want to view this and decide whether or not this is still drawn wrong. That's probably because I didn't recalculate that vector. So let's close and we're on profile. It's a profile. Oh, yeah, outside and to the right. Definitely what we want. Profile 2. Yeah, that looks much better now. Let's get rid of this. Let's run it again. As it's going through, let's talk about hold down. I don't plan on holding it down because of the weight of what we're dealing with. We're dealing with an exceptionally heavy amount of material. I'll show you a photograph of what I'm doing. Okay, here is what we're cutting through. OSB, MDF, 7/16 OSB, 3/4 MDF, 3/4 plywood. This is going to be the bottom. This is going to be the top. The neoprene will go on right on the top of that. Let's continue through this rework. We'll fly through the profile as well till we get to the very end. Wait a minute. Wait a minute. Yeah, so our notch on the pocketing profile is still on the wrong side, which has to be fixed. This needs to be down here. So let's close that. Let's take a look at our Pocket profile. Looking at this, we flipped our profile over, but didn't flip our pocket over, and we do need to do that. So let's get rid of the profile. Let's select this. Let's do our little mirror trick. We did flip vertical, unchecked, create mirror copy. Okay. Close. That's a pocket. Calculate. Delete. Rename. Reset preview. Preview all tool paths. So while that's running, we were talking about hold down. Because of the weight of this is epic. There's no chance I was able to lift this alone. I mean, no chance. It took three of us to safely get this onto the workbench. Down here is our spoil board. Well, our plenum for the vacuum hold down, our machine bed, really. Then there's actually a piece of MDF underneath here that I elected to not show. It's just there. It's a spoil board sitting on top of my spoil board. So hold down. I'm going to pocket without holding down because the material is so epically heavy. I'm also going to turn on the vacuum. I don't think I'll have much holding it down, but I don't think the workpiece is going to move. But when we get the pocket done, I'm absolutely going to fasten through the pocketed area, which we're creating now in our toolpath. I'll throw some hold down in the center here. So the hold down is going to be for the profile only. I don't want that to move. I will have, we'll screw that down. We'll vacuum, we'll screw it down, and we're going to see what happens. Now, the Onsrud catalog is really helpful. That's here because of the chip load calculator and the formulas. So I am using the laminated chipboard, and all of the chip load is coming into the same variables, into the same range. So I'm not real, my lack of experience and substantial ignorance, I'm not necessarily defining a major difference between hard and soft wood and plywood and laminated, etc. This catalog's really helpful. Control home, wood, plastic, composite, honeycomb, and aluminum. So if you're new to this catalog, and you probably aren't, but if you are, it has the beginning of the catalog is obviously an index. It's a table of contents about bit types. Then charts on those bit types and what they're appropriate for. A solid square is going to be best. A silhouette is going to be second choice. So first choice is the black. Second choice is not filled in. And if you're doing MDF, you can kind of just scroll through and keep your eyes on the MDF column and look for bits that are appropriate for it. I'm working simultaneously on a project that we're doing MDF ceiling panels, ceiling tiles. And, using the catalog for that is really helpful to be able to say what does Onsrud recommend as MDF best bits. There are some. Upcut spiral, upcut, well, same tool, just metric. Downcut, depending on what you're doing. For me, it was going to be, they're ceiling tiles, and it's all pocketing, really, is what it is. So the way that I remember it is an upcut is going to be clean on the down or opposite side. I'm going to want downcut because I want to be clean on the side that I'm cutting, but I'm probably going to experiment with both since I have both. I want to minimize the amount of work necessary. I'm wondering, this is taking so long that I wonder if this has unintentionally selected the wrong bit. Perhaps not, but longer than I'd expected. So back to the catalog. You can scroll through, and what's neat about this catalog is the sense that it's very logically laid out. I'm in my hardware life, looking at catalogs is a every other minute sort of endeavor. I've been flipping through catalogs for decades. So what they're giving you here is the series. So let's just continue on with our MDF example. 52-200. That's the series. You search for that, and it's going to take you to the page where you'll find the bits. Because a 52-200 doesn't tell you that it's 1/4 inch or 1/2 inch diameter, etc. Here's the table that will then give you the individual part number for that 52-200 series, what it's used for, a quick description, and there you go. Diameter, length of the cutting surface, shank diameter, overall length, and the quantity of flutes. It's going to be one more pass after this. So that's the way I've been navigating it. And then, as we kind of got through it earlier, you'll get to the rear section of the catalog, and that's where you'll have some calculations, some data that they're going to give you for chip load, etc. Application, single pass roughing, finishing, giving you bit recommendations. It's something that needs to be studied, I suppose, in the sense of obviously testing to see, you know, your mileage may vary, sort of thing. But okay, I was wrong. One more pass. Profile, not just yet. Still doing the pocket. Now we're doing the profile. Okay, does this look like what we need? Yeah, it actually does this time because this is going to be the corner near me.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
This is the corner near me, near my left knee. This is near my right knee. That's the far corner. That's the 5x5 cutout for that conduit because I can't move that. It's there's no slack for me to reroute that. And here's the big notch I have to make. So let's see if that starts to make sense. Actually, let's do this. Can unpin that, unpin that. Looking at it upside down, this is right side up. Yeah, that looks right. That's my notch, kind of like that. This is to get around my PVC, which is over here. That's my 5x5 to get around that flex conduit. I've got my radiuses here. You can see my little radiuses here. Now that looks right. I drew those both upside down. Now, yeah, it looks, does it look good? Yeah, it does. Yeah, there's no reason to pocket that because we just want to hold it off of the PVC. All right, so let's pull up our CAD and CAM. I think it's time to air cut this in the sense that I'm just going to watch how the tool moves. So I'm going to pause this video. I don't know what we'll get into. Actually, I'll stop it. I'm going to zero the machine. I'm going to set my bit. I'm going to set my bit. I'm going to zero all three axes. I'm going to start to do an air cut. And once I'm confident that that's going to work, the next thing maybe is just going to be GoPro watching it cut. So let's do that. So I've begun to air cut everything, and everything looks good. I decided to, of course, take a look at the time. Yeah, that's going to run for more than a day, so we're not doing that. And I know it's because of the step over that I think I'm working on. I've got a really tight step over. I think we can bring that up to 85%. Apply, select, remove, select. Yeah, 85%. Let's recalculate that. Let's get rid of this pocket. Oh, you know what? We're going to have to close pocket, select 85%. Okay. Raster, plunge, start depth is good. Actually, what's concerning is this pocketing and this home position. Yeah, this is fine. Calculate, no vector selected. That would be helpful. Well, it brought it down. We're going to have to run this and then pause it overnight if this is the case. Let's do this. Pocket, let's try a 90%. It's not going to change much. Well, 95. Apply, select, delete, remove. Pretty epic. Well, based on the scale factor, I don't actually know. That was 1.6. That's a value that I've used in the past and found it to be reasonable. I don't know if that'll be the case here. Yeah. So what I'm realizing here is I've recut this, but my step over, I'm going to go back to what it was, but I've realized our cut depth is way too small. Way, way, way too small. So let's go back to our pocket. Let's put this back to 65, apply, select, remove. Now, edit passes. This is where we're getting crushed. Let's make it 1/8 of an inch. Apply. Oh, actually, clear all passes. Let's say 8. Yeah, 8 at 1/8. Okay. Raster, no profile pass. Select, just to make sure, yeah, we're at 65% step over. Edit passes, 8, okay. Edit passes, 8. Set passes, okay. Let's preview this toolpath. Yeah, that looks better. The step over is what caused that, I believe. I don't fully understand it, but let's reset the preview. Let's take this up there. Let's get rid of that pocket. Rename that end pocket. Preview all toolpaths. The idea is that you need to be able to you have to have the setup such that you're making lots of parts, not just one. The overhead to do one or 10,000 is the same overhead in the sense of determining your toolpath. And it helps to be proficient, which is an ever continuing quest. Almost done with the pocket. Just want to get through it so we can see what it's going to look like. Definitely looks like a reasonable piece. Close, time. Yeah, still super long, but 1/8 inch cut depth, can that be 3/16? Probably 50% increase. It's still an epic amount of time to run. Visible toolpaths to one file. Yep. Visible toolpaths to one file. Save toolpaths. The machine is good. ShopBot, the post processor is good. Save toolpaths. Platform. I like it. Save. Okay.
You know what's worse than not remembering how to hone your CNC machine? It's not participating in the Architectural Builder Supply March Contest giveaway.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.